So thank you everyone for sticking around after an intense day. Hopefully this is the treat. So I'm gonna try and show you. So I haven't tested anything in purpose to see what would be the interaction from a user, like so that you see from scratch what is using IPC today, and hopefully I'm gonna glimpse what are the changes that we're doing, because like we have half-baked the release, so I may be able to show you some of the changes that are coming. I don't know if you want to follow this demo with me. If you want to follow this demo with me, please install MetaMask and get some calibration funds, because we will need them. If you, yep.
What's the URL?
Sure, I can actually share these notes. That's a good point. So, any channel, do we know? Oh, that's possible? Ah, in Google. Okay, okay. I thought that part of... Smart. Why? It's the data economy. No, come on. Yeah, but I need to make it... Okay, sorry. Sorry, it cannot be big enough.
I'll drop it in the Slack channel.
Yeah, thank you. All right, I told you I haven't like practiced at all. Okay, so cool. And the goals of this workshop is mainly like showcase what is the current state of IPC and of the stack, gather feedback and ideas. So if you have any kind of feedback of ways in which we could improve the interactions or the stack, please let us know, especially UX. I know that the UX is rough, so anything that you can, any feedback that you can give me either synchronously or if you're watching the video asynchronously, it would be amazing. And then like, please ask questions anytime if there's a concept that is not clear, because if that's the case, it means that something is not, it may not be right in the directions. Okay, so where to start? Remember in my previous talk that I was talking about the IPC agent? This is the best entry point to IPC, because here we have all of the information that we need to start deploying our own subnet and interacting with IPC. So here's the IPC agent, and inside the IPC agent we have like this docs folder with a set of tutorials. And if you go to quick start calibration, this is the one that we're gonna follow today. And in this one, what we have is an end-to-end of how to deploy a subnet on calibration net. We could do the same in mainnet. So the same that we're doing in calibration net would work in mainnet, but I wouldn't recommend it at this point with the stage of development. But like just to showcase that whatever works in calibration eventually will work in mainnet. Okay, and the first thing that we're gonna do, so there are a bunch of preliminaries here that you just need to copy paste to install the prerequisites. I'm not gonna follow those because I already have it installed. And actually, I had to come to this terminal in a machine, and because like it's too slow the current Wi-Fi to download a lot of the things. So yeah, but you could do it in your local environment. So the first thing that we're gonna do is like we're gonna deploy a subnet in calibration as if we were a subnet operator, right? Because like we have different users in IPC, we have subnet operators, and we have smart contract developers. So let's see how we deploy a subnet. So the first thing that you'll need to do is, I mentioned that the key part of our entry point to IPC is the IPC agent. And right now, the IPC agent, it's a background process that needs to be running in order to interact with the system. So we know the first thing that we need to do is start the daemon. Once we started the daemon, what we need to come is here to the, so we have a config for our daemon that here where we describe is the subnets, the different subnets that we want to connect with. Here I have already actually if you do the following, So if you do IPC agent config init, you initialize the configuration and it will populate the configuration for you for calibration already. So here you see that I already have all of the information that I need in order to connect to calibration. Here I have the ID of the calibration rootnet and the gateway addresses, so the addresses of the contracts for IPC that have been deployed in calibration. So with that, we are able to start creating a subnet. And as I mentioned, like to create a subnet, we first deploy the subnet actor. And once we've deployed the subnet actor, we can join and start deploying the infrastructure. So let's, I don't know if I have it here. Nope. Okay, so let me copy paste it from here. All right. Okay, so actually, if you do IPC agent help, you'll see the kind of things that the IPC agent allows you to do. So we have the daemon, which is the one that we run, but you have ways to interact with the config. The most important one, which is the subnet. The subnet category of commands that we'll see is the one that allows us to interact with the lifecycle of subnet. So it would allow us to create a subnet, join the subnet, list information about the subnets, and so on. Then we have the wallet. The wallet, what it does is it handles all of our identities for IPC. And then we have others like cross-message and checkpoint, that those are more for cross-net interactions. So let's create a subnet. In order to create a subnet, the only thing that we need is to, we go to this subnet create, we specify the parent that we want to use. In our case, we want to use calibration, which is R314. As you may see, like subnets, the root of the subnet is determined through the chain ID. So in this case, like the chain ID of calibration net is 314159. If we were like in mainnet, it will be 314. So that's the way in which we know, like, and we identify uniquely the root of IPC. We put some random name at the subnet, and in this case, we're gonna require one Filecoin as minimum collateral for validators, and we're gonna put that the minimum number of validators is 1. Wait a minute. All right. This is going to take time because like we're using calibration, which means that it's 30-second block times. So we may have to wait for a full minute. That is why when I was mentioning like where should we deploy a subnet, these are the kind of things that you need to figure out. Like interacting or going through the rootnet is slow. So you have to pay a price in terms of like the block times and the delay. So here we're just deploying the subnet actor for our subnet. And you see that it's as simple as just using subnet create and like providing a bunch of parameters in order to configure your subnet. In this case, again, like I'm just requiring one Filecoin collateral in order for new validators to join. So in order to participate from proof of stake, you need at least one Filecoin. And then I'm configuring that the minimum number of validators is 1. Usually you don't want this. If you want an amount of security, you may want another minimum number of validators. For demo purposes, I'm going to just use one validator. And by the way, if this is not big enough, I can probably, or not. Ooh. All right. Okay, so here we've deployed, you see that the subnet actor has been deployed and we've been assigned this ID. The ID is assigned according to the address of the subnet actor. So you see that the subnet ID is defined by the parent. In our case, our parent is calibration, and the ID of the subnet actor that defines our policy. So now what we're going to do is that we're going to deploy our infrastructure so that we get an address, a network address, to join the subnet. For this, we already have convenient, let's see, we have convenient infra, nope. IPC infra. Scripts where we can run a subnet in Docker. So this here, what I'm gonna do is actually deploy the subnet infrastructure. So I'm gonna run, in this case, is a Lotus node with this mirror transfer BFT protocol, and I'm gonna run the first node. I'm not gonna start mining. I'm just gonna start the node so that I can get all of the information that I need to join the proof of stake sidechain. So here, it expects a bunch of ports that I export in Docker, and it expects the key that I want to use for my validator. In this case, I already have a key here. I have a worker wallet. Here in the description of like in the tutorial, you have notes on how to create your own keys and how to handle them to save a bit of time. Like I created them in advance. And I forgot that, you see, like it expects 2 ports, and also it expects the subnet ID, the ID of the subnet, which is the one that we received in the previous command. Oh, sorry. I'm not on my terminal and having a hard time. So here is the ID of the subnet. And now we're gonna deploy our validator. And pass the worker wallet, for instance, the first one. Okay, so wait, I may have something already running. Okay, so what this is doing is like I just passed the ID and the worker address, and it's initializing a Lotus node for our subnet. So it's initializing for that subnet ID, and we're gonna, once this finishes, it's gonna give me all of the details that I have to add to my config in order to have my IPC agent connected, and so that we can start mining. So once we have this, we're gonna put some collateral and start mining in the subnet. And with that, like we have our subnet, and we can start interacting and communicating with, in this case, calibration net, that is our parent, as we're gonna see in a moment. This also can take a few minutes. And again, like this is the current state of affairs. I'm gonna also glimpse afterwards, because you see that there are a lot of heavy infra. I mean, there are a bunch of scripts, so it's not that hard, but like there's a lot of heavy infra involved here, like starting the daemon, joining, deploying the infrastructure, and so on. And I'm gonna showcase like how we're trying to simplify it by removing the daemon and a lot of other things with Fenderman. So while this finishes, if there are questions or concerns. This is something that also with Fenderman, because this means starting Lotus, collecting all of the Filecoin proofs, like all of the process of starting Lotus that has a lot of overhead that is Filecoin specific that we don't need, but it's still doing it. And that's why we decided to shift a bit the stack to avoid all of this overhead. Okay, let's check if something is going wrong. Actually, in the meantime, I can show you how to deploy a smart contract or connect to a subnet, because I already have a Fendermint-based subnet deployed here. So I need to make this bigger. Okay, so this is my local environment. And here what I have is a new Fendermin subnet that I already deployed. In this case, you see that it's the root, but like we could have it a child subnet. I already deployed the contracts for IPC, and I'm gonna showcase how an app developer, so far I've been showing how the subnet operator would interact and deploy their subnet, but then we have the application developers, like that are the ones that deploy smart contracts and want to, like they don't care about the infrastructure. So for them, I'm gonna showcase how they can use IPC and deploy smart contracts. So in this case, the first thing that we will need, as I mentioned, like we expose the ETH RPC, so all of the tooling for Ethereum will work for a Fendermin subnet and for a Lotus subnet in our case. And so if we go to the IPC agent, here the first thing that we will do is get the information for our subnet. You see that the chain ID for our subnet is this one, and this is the RPC to connect to it. So the next thing that I need to do is just jump into my MetaMask, for instance, and I need to add a new network. So here you see that I'm connected to the calibration net, which is my parent, and now I'm going to connect to I'm going to add the new network for the subnet, the Fendermin-based subnet. And like, if you want to use Hardhat, if you want to use Forge or any other tooling for the ETH RPC, it's as simple as this one. Like you just point to the right chain ID and the RPC, and you get like the connection directly. And you'll see that it will be faster than what we've been doing over Lotus and over calibration, because we have like 3-second block times in this case. So we're going to add the network. Here we're going to call Fendermin. We put the RPC. And the chain ID. It says that the RPC is giving another. Okay. So we save it, and when we switch to Fendermin, probably I will have already some funds there, hopefully. Oh, I'm already there. Yes. And I can just, I have another account, right? Yeah, let's showcase how to show. I mean, I'm already in a subnet. I'm going to showcase how to send to some other account some funds. So here I could put like 123. And you see that the tooling, like even the gas estimation, everything works seamlessly with MetaMask. And we're in Fendermin here. The transactions should go through, transaction confirmed, and now if I update, you see that like the interaction is the same. And we could even like go to Remix here, connect my MetaMask and deploy my wait, let me reload. Let's get, I should have here a sample contract like this storage contract. We're going to compile it. And now we're going to deploy it over the subnet. So you see that it's getting already the injected provider in Fendermin through MetaMask, and I can deploy it. So it has been deployed, and I could actually like store some number here. You see that it's fast because like we have fast block times, and if we retrieve it, you see that it works perfectly. So this is an example of like how the interaction, like for application developers within the same subnet, it should be seamless to interact with the subnet. It's just the ETH RPC, and all of the tooling, as you see, works from scratch. And let's come back to, and this is the example for Fendermin, but let's come back to our, yeah. This is our Lotus-based subnet that we were deploying. You see that once the infrastructure has been deployed, I have here a bunch of information that I'm given, like the default wallet for the worker address, which is what I sent. And this is really important. So in this case, we're just deploying a single subnet validator, but like if we have more than one subnet validator, we need to announce our network address to the rest of the validators of the network. So when we join, we will have to provide this network address. And this is information that we're giving when we deploy the infrastructure so that we know what we need to do when we join. So now we're going to join the subnet. And for that, I'm going to take here my cheat sheet. And to join a subnet, again, what we do is we do subnet join. It's available in the it's a command in the agent, and we put here the subnet ID, the amount of collateral that we're going to put 2 Filecoins as an example, and we need to put as a network address what is our current network address. Again, like in this case, it won't matter because I'm just running one validator, but if you run more than one validator, you want others to find you in order to create new blocks. This goes to the subnet actor in the parent, which means that we'll need to wait for another minute for this. So if you have questions, it's your opportunity. Yeah.
How can I stake to validate?
This is how we're staking. So you see that we're putting 2 Filecoin collateral. This is how we're staking the 2 collateral to put it as part of the proof of stake power.
Is it the methods of smart contracts, or how can I stake from smart contract, for example?
The same. So this is a smart contract. We're doing it from an off-chain CLI, but these are actual smart contracts. So you can have another smart contract calling the smart contract. Yes, for sure. I'm not going into the code, but like that would work. Yeah, and it worked. We added our 2 Filecoin collateral. Again, like all of these primitives I'm using, I mean, in terms of like showcasing, it's easier to do it through the CLI, but we could even in Remix, deploy in Remix and like have a contract that calls. We don't have a library right now, so you would have to pull the, I mean, we have a contract library, but we don't have a proper SDK. But yeah, you would be able to have a smart contract that deploys a subnet as I'm doing by just calling the smart contract directly. And actually, if we list subnets, this is not my computer, so I don't have, and I don't remember I'm sorry about this back and forth. But like here, I'm gonna check the subnet, and I'm gonna show, like in this case, we should only have a single subnet from calibrate. Oh wait, no, this is calibration. We may have a lot of subnets, actually. Oh wait, not this one. Okay, so I haven't used it. So we're gonna see how many subnets we have in calibration. And for the gateway, we need to put here, I don't have the default. We need to put here whatever. So these are kind of the things, you see, it's a nightmare that you have to remember the gateway address and all of these things. And in the next release of the IPC agent, these commands are really simplified. And I can show, like, we haven't done the release yet, but I have a version compiled so that I can show you. Because right now it would require like coming here, getting the gateway address. This is why I say that the UX is rough right now, but we are making a good job. We should wait 1 second. We need the F4 address. Nope. Sorry. Oh. Okay, I don't know if I'm gonna show you the. let's. This is gonna be crazy. Okay, no way. I cannot copy paste it. Yeah, but like if we had list, maybe I can list subnets. Actually, I can show you the new IPC agent here because we are, as I mentioned, like we want to remove a lot of the process and so on. So instead of the IPC agent, now we're gonna have like the same thing. I mean, if you know ethers for Web3 and like Ethereum chains, we're doing an IPC provider in the same way so that you can interact like from off-chain. On-chain, we will have to work on an SDK also to call our contracts. And in this case, like I'm gonna list the subnets of calibration from here. So, and in this case, I just need to use the subnet because we've simplified a lot the, how is it? This one. I never remember the chain ID for. We use a subnet, and we should get here all the subnets that we have in calibration. That I mean, users are using calibration. No parent found. What? Yep. Yeah. I'm gonna wrap it up in a minute. I just wanted to show the subnet list. Let's see. The parent found. What? Yeah. If you have any questions, like probably the best thing is to try it yourself. But this is the use case of the end-to-end. The issue that I'm having is that I need to do things in the server and things in my local machine because of the slow connection. But as a wrap up, like this is the current state of affairs. You see that we have like subnet operators and contract developers, and eventually we want to merge more the UX so that it's more seamless than we have. Like here, you have to remember a lot of contract stuff and so on, and we are simplifying the IPC CLI so the UX for developers is not as techy, and like you don't need to have this low-level knowledge of how the protocol works in order to figure out. Because like so far it has been built more of a less as a product and more of a technical tool. And the idea is that we're moving into more of a production ready system. We deployed a subnet, we deployed a smart contract. There's a lot of tooling there that I'm not gonna show and that I don't even know if it's gonna work like with this having things in the server, things here. But like any feedback that you have synchronously or asynchronously, please let us know. This was a glimpse of like what is IPC? Hopefully you have a better grasp or not, or I just like completely messed up. We didn't try the crossnet primitives, but like to give you a sense, again, like you could do it from a smart contract. I'm gonna show how it is done here. You have here the cross message, subnet, no, it's just cross message. And you have like two primitives, which is the font and the release currently. Font will inject some fonts into the subnet, so we could include some fonts in our in the subnet that we created. And with the release, what you do is like you have some fonts in the subnet, and you want to send a message from the child subnet up. And smart contracts can also again interact to like instead of using the CLI, you can interact through the smart contract. So we have two ways of interacting with IPC, either three ways, because actually the CLI uses the same. We have the IPC provider, which is a Rust library for your application. That is the one that the IPC CLI uses. And then we could interact directly with the IPC smart contracts in order to trigger any of these operations. So we would expect like smart contract developers and like off-chain application developers to have these two ways of interacting with the system. Thank you very much. Hope these have been useful. It's been kind of a mess with all of this terminal, but like, yeah, hopefully soon the UX will be better. Thank you.
It's just compiled.
Nice. Yeah, I had a lot of prerequisites here because like compiling it and so on. But like if anything doesn't work, please let us know because like there's a lot of rough edges that we have. I mean, we may have blind spots, so
I will run through it and I will be back.
I really appreciate it. And yeah, hopefully it will. The new docs of the new release in a few weeks is gonna be way easier. Now you're gonna be super frustrated, as frustrated as we are. Thank you.
Thank you so much.